Isaac Newton, literally quoted, my goodness, it discovered so much. How Newton's rings are formed. Set up. A plane convex lens is placed on a glass surface, right? Okay. And a monochromatic light source is directed at the setup. Light reflects off surface, both the bottom surface of the lens and the top surface of the flat glass. So I think we need a visual image of this. Let's try to explore some GPTs who can provide a visual image of this. I'll right back. So we got this image generator. Let's see if what type of image does this generate. Well, I thought you were an image generator. Can you generate a visual image of the process? I could have asked ChatGPT for it. Anyways, it's generating. The image generation did not work out for some reason, but anyways, we just continue with our study. The reflected light waves from two surfaces interfere. Light reflects off both the bottom surface of the lens and the top surface of the flat glass. Reflected light waves from two surfaces interfere. Depending on the path difference, constructive interference creates bright rings and destructive interference creates dark rings. Pattern description. So there are concentric rings. The patterns appear as a series of alternating bright and dark circular rings centered at the point of contact between the lens and the flat surface. The cause of it is the thickness of the airfilm varies radially outward from the point of contact, causing variations in the path difference of light waves. Mathematical analysis. Condition for dark rings. Destructive interference is 2t, 2m plus 1 lambda by 2, where t is the thickness of lambda. T is the thickness of airflame, lambda is the wavelength of light, and m is the order of the ring. Condition for dark reference constructive interference 2t and lambda. I think it's the opposite of this. Radiation of rings is under m lambda r. Okay, cool. M lambda r, huh? Applications where the Newton ring is used. By analyzing the ring pattern, the wavelength of light can be determined. Testing surface flatness. Variations in ring pattern can reveal imperfections in the flatness of optical surfaces. And determining refractive index of liquids placed between the lens and glass plate. The center ring is dark if the light is monochromatic, as the path difference is zero, leading to destructive interference. And the ring spacing decreases as the distance from the center increases because the curvature causes small changes in the thickness at a larger radii. Okay guys, we are just watching a
Newton's
video
rings.
of this Newton's rings.
The phenomenon of Newton's rings, named after Isaac Newton, is an interference pattern caused by the reflection of light between two surfaces, a spherical surface and an adjacent flat surface.
Cool.
When a parallel beam of monochromatic light is incident normally on a combination of a planar convex lens and a glass plate, a part of each incident ray is reflected from the lower surface of the lens, and a part, after refraction through the air film between the lens and the plate, is reflected back from the plane surface. These two reflected rays are coherent, hence they will interfere and produce a system of alternate dark and bright rings.
Right.
Apparatus: monochromatic light, wooden mount, This is a rectangular shaped box at the bottom of which we place plain glass, material, and the lens. Light is directed to the lens through this reflector. Optically flat glass plate. A planar convex lens. Traveling microscope. Procedure. Turn on the sodium lamp. Place a planar convex lens on the plain glass plate with curved surface in contact with the glass plate, and place this system inside a mount placed under a traveling microscope. The reflector on the mount will direct light onto the optical system. Focus the traveling microscope to see the bright and dark circular fringes. Fix the vertical crossbar of the microscope on the 20th bright ring at leftmost end and record the reading on the horizontal scale. Repeat these measurements for microscope movement from left to right and evaluate the diameters of different rings. Calculations. The main scale has 20 divisions in between 2 cm readings, and the vernier scale has 50 total divisions. So the least count of microscope is 1 by 20 divided by 50 is equal to 0.001. Take the reading of main scale just before the 0th position of vernier scale. Only one line of the vernier scale will coincide with the main scale. Take the reading of that point from vernier scale. So the reading can be calculated as main scale reading plus the product of vernier scale reading and least count.
Cool. That's it. Simple as that, right? Thank you for watching, people.